Continuing on the topic artificial neuron, the artificial neuron is also referred to as perceptron. This is the standard diagram of an artificial neuron, and it shows the basic functions of the perceptron. And similarly to the dendrites, the perceptron has its inputs. You can have as many inputs as possible, and then it feeds in the input. Well, think of it as an input layer. This information layer, what we call the input layer, it passes the inputs through to the neuron in the way that the dendrites would. And you would notice that we have these W's, and these are all weights associated with each input. And then we have the activation function. Think of it like the soma, the cell body, where the processing of the input happens. What it does is that it takes the sum of the input multiplied by the weight and passes that through an activation function. So like I said, it's a mathematical model to our biological neuron. And depending on what happens in here, depending on the activation function, it gives a binary output whether yes or no, whether or not a neuron would be outputted. So the four essential parts of the perceptron is the input layer, the weights and the bias, the activation function, and then the output layer. In the next lecture, I explain the weight and bias in more detail, so don't worry about that right now. And also in later parts of the course, I would also revisit the topic of weight and bias when we get into more examples of deep learning. But for now, I would like you to just understand the perceptron, the layout, the main four parts of it. And now I would like to give an example of how on earth this ties into NLP, or the analysis of text data. One example would be determining the sentiment for movie reviews. The sentiment meaning if it's good or bad. So the input would have our movie reviews. So after watching a movie, we can have hundreds and thousands of movie reviews for a particular movie. It would be too much for a human to go through and do overall score of the movie. So we have the input, which will be all our reviews, our movie reviews. And then each one will have its weight and bias associated with it. Don't get confused with the weights again, I will explain that shortly. Then when the inputs and the weights is passed through the activation function, it tries to figure out, okay, does these words of that review, if the review says I love this movie, it has to figure out and calculate how positive that statement is. I love this movie, and the keyword here me being love. Later on, when we do word embeddings and cosine similarities, you would understand how the algorithm has an idea of the context or the meaning of that word. Then it figures out if it's a good or bad review, so it outputs that sentiment. So we get the sentiment analysis for all our movie reviews, and it will tell us if it's good or bad. That's if we do a polarity type of sentiment analysis. That's based on good or bad, but we can also do a more granular sentiment analysis, and it can output the emotions. If generally people were angry, or like extremely upset about the movie, or generally really like it, so it's very positive. So that's essentially classification, and we do text classification later on in the course. One of those examples would be the text classification section, where you're introduced to classifying reviews for the first time on Steam reviews, so you can look out for that later on. So join me in the next lecture where we learn a bit more about the weight and bias within our perceptron.